Hello and welcome back. Let's do one final example of some partial fraction decomposition. So we want to find the partial fraction decomposition of this fraction here. And what you'll notice is that the denominator is not factored, which is a little bit of a problem since we don't know how to, what partial fractions we'll need to write on this side. So the first order of business will be to write this as a fraction whose denominator has been factored. So step one, factor this guy. When we want to factor a polynomial, so this is just like we saw back in chapter 3, we need to find a zero of the polynomial, and then we can factor out x minus that zero. So the possible rational zeros are going to be the factors of -4 divided by the factors of 1. So they could be plus or minus 1, plus or minus 2, or plus or minus 4. So let's just plug in these in order to try to find a zero. So if I plug 1 into here, so if I have 1 cubed plus 3 times 1 squared minus 4, we do get 0. So first try we get a 0. So we know that 1 is a 0. If 1 wasn't a 0, I would try -1 and then plus 2 and then -2 and then plus 4 and then -4, and I would just search until I found a rational 0. We got lucky, and first try we found a rational 0. So that means that x cubed plus 3x squared minus 4 is going to have a factor of x minus 1. Here 1 is the 0, so x minus 1 is going to be a factor of this. And it's going to be times something. So once I factor this out, I'm going to be left with something else. So how do I find this? Well, just like with a number, if I have something is equal to two things multiplied together, and I want to find this one, I'm going to divide this side by x minus 1, and that'll be what's left over. So now we have to do some long division. X cubed plus 3x squared. There is no x term, so I'm going to add a 0x minus 4, and I'm going to divide all of this by x minus 1. X cubed divided by x is going to be x squared. So x squared times x is x cubed. X squared times -1 will be negative x squared. I subtract the bottom line from the top. So x cubed minus x cubed is 0. 3x squared minus a negative x squared, since we're subtracting a negative. It's just like adding. And then I'll drop down the next one. So x goes into 4x squared 4x times. So 4x times x will be 4x squared. 4x times -1 is negative 4x. And now I have 0x minus a negative 4x. So when I subtract a negative number, it's just like adding, and I'll have 4x minus 4, and x minus 1 goes into this exactly 4 times. So 4 times x, 4 times -4, we have a remainder of 0, which is good. So all of this was done for the following reason. I can now say that x cubed plus 3x squared minus 4 is equal to x minus 1 times x squared plus 4x plus 4. We're nearly there. Last step, I can factor this guy right away. This is just a quadratic expression, and it's easily factorable. It is x plus 2 times x plus 2. Again, 2 times 2 is 4, but 2 times 2 plus 2 is also 4. So when I write this down, I see that we have x minus 1 times x plus 2 squared. So I have just factored x cubed plus 3x squared minus 4. Now I can write down my partial fraction decomposition. My original fraction was just 1 divided by this guy, x cubed plus 3x squared minus 4. But I know that I can factor that into this. And with my partial fractions, I have 3 factors on the bottom. This one is repeated, so I have 1, 2, 3. So I have one fraction that will be x minus 1. I have one fraction that will be x plus 2. And I have one fraction whose denominator will be x plus 2 squared, because it happens twice. And the tops of the fractions, we don't know. So we'll just have to do a little bit of work to find out. Again, I'm going to multiply everything by this denominator to try to cancel some things out. So if we multiply the left-hand side, x plus 2 times 1 over x minus 1 times x plus 2 squared be equal to x minus 1 times x plus 2 times the first fraction. Oh, everything should be squared, as in, sorry, the x plus 2 should be squared because that's what's on the denominator there. Plus x minus 1 times x plus 2 squared times b over x plus 2. And then the last one, x minus 1 times x plus 2 squared times, and I've run out of room, c over x plus 2 squared. Apologize, had to fit that in there. So what cancels? All of this cancels with all of this to give us just a 1 on that left-hand side. I'll scoot everything to the left. X minus 1 cancels with x minus 1. So I've got x plus 2 squared times a. Over here, I have an x plus 2 cancels out with one of the factors of x plus 2. So I'm left with x minus 1 times x plus 2 times b. And then over here, the x plus 2 squared and the x plus 2 squared will cancel. And I'm left with x minus 1 times c. Cool. What's left? I want to expand all this out. So x plus 2 squared, that is x squared plus 4x plus 4. And all that's times a. X minus 1 times x plus 2, when I FOIL this, I'll get x squared. I'll get a 2x and a minus 1x. And then a negative 1 times a 2, so that's minus 2. And then the last one, I'm just going to leave as x minus 1 times c. And now I will distribute all of my a, b's, and c's. So this is going to be x squared times a plus 4x times a plus 4 times a. This will be x squared times b plus x times b minus 2 times b plus x times c minus c. We now have this very long equation, but we know that all of the terms on both sides of the equation will have to match. Here's a term without an x. 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 So 1 is going to be equal to 4 times a minus 2 times b minus c. Let's look at all the terms with 1x, not x squared, but just x. So here's x times c. Here's x times b. Here's 4 times x times a. And on this side, I don't have an x term, so I'm just going to write a 0x on that side. So 0x is going to be equal to 4 times x times a plus x times b plus x times c. And then the last one, we have some x squared terms. So we have an x squared term there and an x squared term there. Nothing on this side, so I'm just going to write an 0x squared. So I have a 0x squared term over there. I have x squared times a plus an x squared times b. Lastly, to make these into nice equations, I'm just going to divide both sides of the second equation by x. So dividing by x gets rid of all of these. And dividing this guy by x squared gets rid of all of these. And now we have three equations with three unknowns. The third equation only has an a and a b in it. So I'm going to take the top two equations and I'm going to use them to cancel out the c right here. Please excuse my noisy furnace. So the c, the negative c and the plus c will cancel. When I add them together. So the c and the c will cancel out. Negative 2b and b, oh, that adds up to negative b. 4a and 4a, that adds up to 8a. And 1 plus 0 is 1. So now I have this equation, which is a plus b is equal to 0. And I have this equation, minus b. And when I add these guys together, I get 1 is equal to 9a. Again, the b and the negative b will cancel out. So a is going to be 1/9. Fraction is not very nice, but as far as fraction goes, 1/9 is not too bad. And then when I look at this bottom equation, a plus b has to be equal to 0, which means that 0 is equal to 1/9 plus b, so b is going to be equal to negative 1/9. So far, so good. And then I'm going to plug this into this middle equation. It says 0 is going to be equal to 4a plus b plus c. So 0 is going to be equal to 4 times a, which is 1/9, plus b, which is negative 1/9. My 9s don't look like 9s, plus c. So this is going to be 4/9 plus negative 1/9, so it's going to be the same as negative 1/9 plus c. And when I subtract these, I will get 3/9. So c here, and when I subtract 3/9 from both sides, c will be negative 3/9, which is the same thing as negative 1/3. And those are my coefficients for my partial fraction decomposition. Oops. So right here, I can substitute a, b, and c in to get my decomposition. So if I just plug them in right here, 1 over x minus 1 times x plus 2 squared is going to be equal to 1/9 divided by x minus 1 plus I've forgotten, negative 1/9 divided by x plus 2 plus negative 1/3 divided by x plus 2 squared. So this was a lot of work. And essentially what it does is it gives us some fractions that have smaller denominators, and these will generally be easier to work with than the bigger fraction that we started with. And we even had to factor the bottom of the original fraction, which wasn't even factored for us.